Okay, and we're actually going to start with the distance formula. I think on the assignment, I forget on the assignment if we do it, which one we do first. But we're going to do both of them. All right, so the distance between A to B on a number line is so very easy to determine. Okay, basically it's the same thing as the change of A to B, or the change in X would be the number line, right? So this is all it is. B, and I'll put a 1 because it's the first point, minus A. That's the distance. So we don't really need a formula if we're doing a number line. Okay, but basically you start with the second thing and subtract the first thing and get the distance. And so I'll give you an example. Let's say that this right here is 0, this is 4, and this is 14. What's the distance between A and B? 10. You can even do that in your head, right? That makes sense. If you start at 4 and go to 14, that's 10. So you just did 14 minus 4. So that's the basics behind this. And so what we are going to do is not worry about the distance on a number line, which is easy to count. We're going to worry about the distance of this shape right here. Okay? Of course, I'll cover that up. It's too late. All right. So the Pythagorean theorem is another thing that you should have gone over just a little bit. But if you didn't, that's okay. Usually it's taught like this. A squared plus B squared equals C squared. Do you remember doing that a little bit?
No. A little bit, but I don't think I learned very good.
It's not much to it. You just take the numbers and put it in here and you get... And so we'll kind of go over this a little bit, how this works, to make sure you know. The distance formula actually comes from the Pythagorean theorem, and I'm going to kind of show you that. Geometry is not just how to do it, it's why we do things a certain way. And so even though you're going to use the distance formula, I want to show you where the distance formula comes from. And so we're going to do that real quick. So what I can do to find the distance between MK is I can draw a triangle. That's one thing we do in geometry a lot, is we draw triangles to make things easier. And maybe at your seat this is going to be hard to count, but I basically set this up like a right triangle with the Pythagorean theorem. Okay? And then I do have a graphic of how the Pythagorean theorem works, in case you were wondering. This is actually a proof of it. This would be like A squared, so that would be 3. This would be like B squared, that would be 4, and that's going to equal C squared, which is 5. Okay? And so you can see 3 squared literally means 3 turned into a square, makes 9. 4 squared literally means turn it into squares, equals 16, right? And 5 squared would equal 25. So this is actually the proof of the Pythagorean theorem, if you've ever seen it. There it is. Yay. All right. So I'm going to do this. And the nice thing about straight lines is I can count. 1, 2, maybe. 1, 2, 3, 4, 5, 6, 7, I think. Yes. So A squared would be 7 squared. B squared would be 1, 2, 3, 4, 5, 6, 7, 8. Would be 8 squared. And that's going to equal C squared. Okay? So I'm just going to put that in the calculator real quick, because I don't need you to be able to do that manually. That would be 49 and 64, but it's okay. So I get 113, right? Okay. And does anybody remember the last step to solve this algebraically? Square root. That's really what I needed out of this. So the square root of 113 is, well, it doesn't simplify, does it?
You gotta hit the toggle button at the bottom.
No, this is the answer.
Oh, really?
Yeah. That's as simple as it gets. This is called an exact answer. A lot of times in math, we want the exact answer, not, that looks terrible, not the rounded answer. and you are correct to get the rounded answer for science or something, we might hit the toggle button and get a decimal, yes? A lot of times in geometry, we don't want this until the very last step. So we're going to leave it like this today. Does that make sense? Yeah. Okay. I hate this answer, but it doesn't simplify, so we leave it like this. All right. So that's how to do it with the Pythagorean theorem. But the problem with the Pythagorean theorem is, guess what you have to do every time to use it? You've got to graph it. I don't want to graph it. Graphing takes too long. I would rather just take my raw data, my numbers, and get an answer. And so I'm going to show you how this is going to work here. And we're going to see if we can get this done using the Pythagorean theorem. We're going to convert the Pythagorean theorem into the distance formula. The midpoint formula is easy. Don't worry about that. So that's what I'm going to do. So basically, using real paper is weird. Basically, what I'm going to do is I'm going to use these points, x1, y1, and x2, y2, okay? And I'm going to turn it into the distance formula. So what I'm going to say is the distance of A and the distance of B. So I'm actually going to do the distance of B first. I'm going to do B squared plus A squared equals C squared. Doesn't really matter. And so basically the distance between this point and this point would be x2 minus x1. That's what we discussed on this. You don't see that at all. Where is it? There it is. Oh, let me just write it down. The distance on that is going to be x2 minus x1. That's what we discussed the distance between 2 points on a number line is, right? Okay. What did I do? Yeah. That's what we discussed. All right. And so that's going to be the distance there. And so I'm going to square it because it's the Pythagorean theorem. What's going to be the distance between these 2 points? y2 minus y1. And I'm going to square that. And that is going to equal c squared. That's what we want, right? Okay. And you said that the final step is what? Take the square root? So I'm going to do that. I'm going to take the square root of this. I'm going to take the square root of this. Okay? And so instead of writing it like this, I'm going to write it like this. C equals the square root, and this is the distance formula. x2 minus x1 squared plus y2 minus y1 squared, all under the square root. In your book, I see it a lot of times, instead of C, we have D for distance. In your book, we're going to do this. Why did I use MK? Where would I get MK from? The graph? This literally says the distance between M and K, right? That's the distance between M and K. So let's go ahead and try this. And again, the graph is kind of hard to read, so I'm going to write you the points. Let's see if we get the same answer. And then we're going to practice this a little bit. So the points on here are, let's see here, 0, 7. And the point on here is 8, 0. Let's see if we can find the distance between those 2 points using this formula. And this is the skill that you're going to need to be able to do for the test and for the homework today. So I'm going to show you how to put this in. So the distance between MK is going to be equal to, let's see, x2 is 8 minus 0 squared plus 0 minus 7 squared. Is that right? Did I put that in right? Okay. You can put this all into the calculator. or you can do it step by step. This, of course, would be 8 squared. This would be negative 7 squared. This would be 64 plus 49, all square rooted. And so it's going to also, it's not going to be negative 49. Negative times a negative is a positive, right? So negative 7 times negative 7 is 49. And so this is going to end up equaling MK equals same thing, right? All right. And be careful on your calculator. Let's see if I can make this clear. If you type this in, like this, you get negative 49. You're going to get the wrong answer. What the calculator thinks you're doing is 7 squared and make it negative after you finish the problem. When you square anything negative, you have to do it like this. That way it squares the whole thing. If you can get this right, it's going to avoid a lot of mistakes. Okay? Do we see that? Be careful on that. Because you'll do everything right, you just won't put the parentheses and you get the wrong answer. All right, let's try another one of these problems. And this time I'm going to give you harder points and see if we can get the right answer. I'll give you 2 points. I don't want to graph this one at all. Because this is supposed to be faster. Formulas are supposed to be faster. They're not always faster. Here we go. Let's go see what the distance is. And I can call this, we'll call this point A, and we'll call this point B. So the distance between A and B is going to be 1 minus 4 squared plus, and I'm going to put this in the calculator all the way so you can see how you can do it. Negative 8 minus 6 squared. These are my y's, right? 8 and 6. These are my x's. See if you can get it right. I'm going to put it all on the calculator. And the nice thing about this calculator is you can make it look right. Some calculators you can do it, but you don't make it look right, and that's why I do step by step. This is also frustrating if you make a mistake. You've got to start over. Here, I'll do that so you can see it sort of. And remember on these calculators, on almost all calculators, negative and minus are different. So like for negative 8, I had to type in negative 8 minus 6. So I had to use this one for negative 8. And I'd use this one for minus 6. Okay, also when I put it in my calculator, notice there's a line over the entire thing. That's what we want, right? So it should look exactly like what is on the page. Let's see what I get for an answer. I can't even simplify this again. Okay, that's okay. All right, it doesn't get harder than this. It is what it is. There's not levels for this. It is just one level. That's it. Okay, I'm going to move on. I'm going to move on to midpoint formula. Midpoint formula is easy. We probably need to understand what a midpoint is. Okay, so before we get that, let's write what a midpoint is. So a midpoint is equidistant. I think I spelled it right. I'll double check it here in a second. What do we think equidistant means? Equal distance, same distance, is equidistance from two endpoints. Okay? Let's look at this other definition before we get into the formula. A segment bisector is a point, line, ray, segment that intersects a line segment. You can't see anything I'm writing. A point, line, ray, line segment that intersects a line segment through, what do we think? The midpoint. Okay. So let's get the midpoint formula now that we wrote all that stuff so you know what a midpoint is. We're going to use midpoint and segment bisectors a lot. So you need to know what a midpoint means. Okay? So first of all, the midpoint is going to let us know, and we're going to figure that out, that this line segment equals this line segment. And see what I just did with these red lines? That means that this line segment equals this line segment. And here's the formula. I need a different color. x1 plus x2 divided by 2. And this is a comma. y1 plus y2 divided by 2. This is going to give us a point, right? So the midpoint is this. Okay, there are two levels of this. There's the easy and there's the medium. And I'm going to show you that, and then we're going to be done. We'll see how, well, yeah. So I'm going to show you both of these. So here, we got the formula? Yeah, question?
I didn't finish copying the second one.
The second one? Here, let me keep going, and I'll give you this piece of paper, just for time, or I'll put it back up. All right, so let's just do a question real quick. 4, 6, 8, 1. I want to find the midpoint. This is all you do. 4 plus 8 divided by 4 plus 8 is 12, divided by 2 is? Okay. 8 plus 1. I'm sorry. Y is 6 plus 1, right? Divided by 2 is? And that's my midpoint. Let's see if it makes sense. If I wrote this in a pattern, 4, 6, 8. That makes sense, doesn't it? 4, 6, 8? Let's see if this other one makes it the same pattern or a similar pattern. Let's see here. That would be, Y would be 1, 3.5, 6. That's a pattern too, right? Okay. This is called a linear pattern, right? This is following a slope. We're not doing slope today, but it does. And I'm going to actually stop here. We're not going to do the middle level. We don't have time. We'll do the middle level tomorrow. So that I need to give you your assignment.